Hello, this is Taseer.
This is Karim, and we're here to do some cool math problems.
Okay, so we were assigned question number 6 from the review section for chapter 5, reading, for each of the following functions, 1, find y is equal to a function of x, the result of a translation that is moved to the right 1 and down 2, and this can be told from the vector here, where the 1 represents a shift for all the x values to the right 1 and down 2 for the y values, down -2. Okay.
So we are asked to come up with an equation. Well, we have to, and to represent this shift. So y equals 1x is the original function, and we wanna rewrite it to make it to make the graph shift 1 to the right and 2 down. So it's gonna be y equals 1 over x minus 1
minus 2. Okay, to sketch the original function and its translation function on the same set of the axes, we will now graph the two functions. And the original, first we'll graph the asymptotes that come with this equation. So the first asymptote would be at x is equal to 1, which is our vertical asymptote, and our horizontal asymptote will be at -2, which is found by which is found by where we will replace the x here, 1x, and 1x divided by x gives us 0, so you're left with this, which will be our y value for our horizontal asymptote.
Of course, the original function doesn't have the asymptote, so in a bit we're going to go ahead and graph it.
Okay, so let's graph the first vertical asymptote on 1 all the way down, and the horizontal asymptote at -2. Okay, now we'll draw the original function. It goes something like
The asymptotes are, of course, for the second graph, while the original function doesn't have asymptotes. So this is the original one.
okay.
And now we're going to draw the second graph with the asymptote.
Which will look something like this.
Let's change the colors.
Let's change the color.
Like this. And like this. As you can see, following the new asymptotes.
Okay.
Okay, so now we are asked
To find the domain and range of each of the functions, which for our original function, which is
so for the original
y is equal to 1 over x, it would be, the domain would be all real numbers. Yes.
Yeah.
So x such that x is all real numbers, and the range would be y such that y is not equal to
0.
Okay, sorry, for the domain, the x's will also not equal 0, so the domain would be x such that x does not equal 0 for the original function of y is equal to 1 over x. But for our new function, which is y is equal to 1 over x minus 1 minus 2, our domain is going to be x such that
X cannot equal 1.
x cannot equal 1
And of course
because
you can see
it
in
would
the
be division
asymptote.
by 0 and the asymptote.
And the range
Range is
y such that it can't equal -2. And again, it's because of the asymptotes that we tried earlier.
because the asymptotes for this question pose as limits for how far the graph can go down.
And now let's go ahead and do question number B.
Which is y is equal to 2 raised to the power of x.
Of x.
So our original is y is equal to 2 raised to the power of x. Now we have to create a new equation that will meet the requirements of our vector here, where the graph has to move right 1 and down 2.
Therefore, it's going to be y equals 2x minus 1 minus 2.
Minus 2.
And that is our new function.
Because with this, the graph moves over to the right 1 and then down 2. Okay.
So let's go ahead and graph it. So for the first, our original graph, it will look
Which
like
is y is equal to 2x. We can graph that as, let's switch colors real quick.
so we will graph it. It would look like something like this. We have a point here, which is 1, because when x is equal to 0, here it will look it's going to equal to 1. So let's go ahead and graph it. And so that is our original function. And for our second function, of course the graph is gonna move down, but we can put it as an asymptote. So here we're gonna have an asymptote here, which is gonna be y equals -2. And we're gonna have a point here, which its coordinates will be 2, 0. Well, you must be wondering where we got the 2, comma 0. Well, it's actually not this point, but it's the point after. So because when x equals to 1 at the original function, it's gonna equal to 2. So when you take this point,
You move it up to 2.
and exactly, you move it 1 to the right and 2 to the 2 down. We
It
will
comes
have
back
this
to
point.
0, so you're left with 2 comma 0.
Exactly. And now we are going to graph our second function, which is gonna look something like
When
this.
graphing the second function, please be careful to not pass through your y is equal to -2 as an asymptote, because it's a limit to the graph. And if you do, it would be incorrect, because these graphs have asymptotes to a point where the lines can never touch 0.
Okay. So
Now for domain and range.
for domain and range.
So the domain of our original function is, which is y is equal to 2 raised to the power of x, so the domain is x such that x is all real numbers, and the domain is for y, or sorry, the range is y such that y is greater than 0, because as the x is moved, the y comes closer to the 0. Okay, and then for the domain and range for our second function, the domain is x such that x is all real numbers again.
And the range is going to be greater than -2.
So we would say y such that y is greater than -2, because it's also a limit to how far a graph can move.
And that can be seen, of course, with the greater than -2 in this asymptote here that we had when we shifted down to.
Thank you for watching.
Hope you enjoyed this.
Hope you
Good
learned
luck.
something. Good luck.